Hi and welcome to my YouTube channel. In this video we're going to talk about an open source hardware system on a module and evaluation board from Olimex. It is with NXP i.MX8M+. This is a system on a chip that is widely used in the industry. Here I have Olimex system on a module with NXP i.MX8M+ and 4 GB of RAM, as well as this big carrier board for the system on a module. Both of these boards, the system on a module and the evaluation board, come in a cardboard package. The carrier board comes with rubber feet that I have already added. I have also added my own microSD card. First, let's have a look at the system on a module. Olimex has chosen a long and quite inconvenient name. Let me try to pronounce it. i.MX8MP SoM 4 GB IND. The last three letters are for industrial. It is built around the i.MX8M+ system on a module that features a quad-core ARM 64-bit CPU and Vivante GPU. On the left side of the system on a module, there is an LVDS connector which allows you to connect a display. There are two MIPI-CSI connectors which are for cameras. One of them is on the left, the other one is on the right. Between the two CSI connectors there is a MIPI-DSI connector, which means that you can also attach a display serial interface and another display through it. Olimex have designed and they're selling this system on a module with 4 GB of LPDDR4 RAM. This is an industrial grade system on a module because it works at extended operating temperature range from -20 degrees Celsius to 85 degrees Celsius. On the back side of the printed circuit board there are female header pins to attach the SoM to a carrier board. As you have already understood, in order to use the system on a module, we need a carrier board, and Olimex are providing an evaluation carrier board for their i.MX8M+ system on a module. It has a lot of connectors for various peripheral devices. From left to right, we have a barrel jack for 5 volts DC only. This is how you power on the board and the system on a module. Next to it, there is an HDMI connector. There are 2 connectors for CAN bus. There are also 2 Ethernet connectors, and we have a headphones and a microphone audio jacks. On the bottom of the board, from left to right, we have flash header, a microSD card slot which I'm going to use in order to boot an operating system on this board and system on a module. There are 2 USB 3 ports, there are power and reset buttons, and also an NVMe, so you can attach an external storage. On the left and the right side of the board, you will find connectors with additional GPIO pins, including I2C, SPI, and UART. There is also a boot switch on the right upper corner. On the back of the printed circuit board, you can find detailed instructions how to configure different boot modes using this switch. SoM stands for System on a Module. It features System on a Chip, SoC, so make the difference between SoM and SoC. Also RAM memory and some peripherals. SoMs are widely used in the industry because this way you can have a common part that's difficult to design and you can get it from someone that has already designed it, and you can focus on designing your carrier board on which you attach the system on a module. This is very convenient for industries where you don't make millions of devices, but you have to make a few hundreds or a few thousand devices that have very specific peripherals, so you can focus on the design on the carrier board and your peripherals and rely on a system on a module that just works. In this case, the SoM here is from Olimex and it features NXP i.MX8M+ system on a chip. In order to use this system on a module, you have to plug it on a carrier board, and Olimex have also designed an evaluation board on top of which you plug the system on a module. Let me show you how this is done. The process is super easy and straightforward. You have to pick up the system on a module and carefully place it on top of the evaluation board. The evaluation board has male header pins and the system on a module has female header pins. You can't make a mistake because they can fit only one way. For further assistance, there is an indication on the white seal screen of the system on a module. It's placed on the left upper corner. Olimex is a Bulgarian company. They have an office here in Plovdiv. Plovdiv is my hometown, so we're good friends with Olimex. However, I bought this board with my hard-earned money. So this video is not sponsored, and I put a lot of efforts in order to port the Yocto community BSP layers so that I can build a custom image for this system on a module and the evaluation board. Olimex is well known because they manufacture and design open source hardware. They use free and open source software to do this. The software that they use is called KiCad. This is a free and open source software application that runs on Microsoft Windows, Mac OS and Linux distributions. I'm personally also using KiCad and I'm using it on Ubuntu. It works pretty well. These boards are quite complex. They have multiple layers and it's a state-of-the-art in terms of design that has been done with free and open source software. Well done to Olimex for doing this. Both of these boards are open source hardware, so Olimex have shared all KiCad design files at GitHub and they're available for a free download. Also, you can download an image built with build-root to boot the board. However, I'm not going to use it because the image provided by Olimex is based on build-root that's 2 years old. So instead of that, I'm going to use something else. The Yocto project is a collaborative project of the Linux Foundation that uses the Open Embedded Build framework and a tool called BitBake so that you can build your own custom images. There are community maintained board support package layers for NXP, previously known as Freescale, and I contributed some patches upstream so that I can build custom images with Yocto and Open Embedded for this Olimex board with NXP i.MX8MP+. Using these upstream contributions, I have already built an image featuring Wayland and Weston. Wayland is a graphical display protocol and Wayland is a reference and compositor for Wayland. This is a simple demonstration that I can show you graphical user interface running on a custom Linux distribution for this i.MX8MP+ board. Building even a minimal custom embedded Linux distribution is a very time-consuming process because first you have to download the source code and after that to cross-compile it. In this case, I've cross-compiled it on a very powerful machine with AMD 64-bit CPU for the NXP i.MX8M+ ARM CPU, which we have on these Olimex boards. After that, I flashed it on a micro SD card, and here you see how I'm wiring everything together. I'm plugging a HDMI monitor, a USB keyboard and a mouse, and also of course the micro SD card on which is my custom image. It is very important to note that the evaluation carrier board from Olimex supports only 5 volts, so I'm using an appropriate 5 volts direct current power supply. Using the magic of video editing, we can speed up the boot sequence. Here I have core image Weston. This is a very minimal image with systemd service that starts Weston, the reference compositor of Wayland. Wayland is a communication display protocol. NXP i.MX8 supports it, and there are close proprietary drivers for the Vivante GPU, which provides hardware acceleration. I'm using kernel 6.6 with these drivers here. Also, it's possible to build a mainline kernel with the Etnaviv open source drivers. This is something that I have in mind for my future work. I know that NXP i.MX8M+ is not very popular among makers, but it's widely popular in the industry, and I'm sure that a lot of people watching this video will have hands-on experience with i.MX8M+. If you are using the Etnaviv driver, please leave a comment below and let me know what is your experience. Do you have any problems with the open source driver and how it handles for your use cases? By the way, I have also ported the open source software over-the-air update solutions Mender and Rauk, and you can choose one of them and use it with a Yocto based builds for this board with i.MX8M+. Thank you very much for watching this video. Having a system on a module is really convenient and widely used in the embedded Linux industry. However, it's not so popular among makers. So this is a really interesting board because it is open source hardware, features a very powerful system on a chip such as i.MX8M+. It comes at a very reasonable price. Actually, it's one of the best prices that you can get out there for this system on a chip as of the moment. Olimex have done a really good job designing an open source hardware board around NXP i.MX8M+ using the free and open source software KiCad. It's definitely a board that you should consider if you are interested in open source hardware. Thank you very much for watching this video. If you enjoyed it, please hit the like button, subscribe to my YouTube channel, and stay tuned for new videos. See you soon.